Before we start to write the program, we first need to select a name that is representative of the facility shown here. Within this machine, we have these two level switches and this stop switch. These are the machine's inputs. The outputs are these two pumps, the mixer, and this valve. If the low level, high level, and stop switches are connected respectively to the first, second, and third inputs of the PLC input module, their addresses in sequence will be I00, I01, and I02. Similarly, if pumps 1 and 2, the mixer, and the valve are connected respectively to outputs 1 to 4 of the PLC's output module, their addresses will be Q40, Q41, Q42, and Q43 sequentially. Okay, now that we know all the addresses of the inputs and outputs, we can go to the option menu and open the symbol table to give each address a representative name. We enter the name L level for the low level switch and leave the type as Boolean because the switch is digital. We continue naming the addresses with representative names until all addresses have a name. Then we save the table and navigate back to the OB1. Okay, so as we did before, we want this switch here and both pumps to be energized when the level of the liquid in the tank drops to the minimum. We do this by inserting an SR flip-flop from the bit logic folder here. The functions of the flip-flop are quite basic. It has 2 inputs and 1 output. When the set input is energized, the Q output is true, and when the reset input is energized, the Q output is false. So now, we're going to add 2 coils. One will be assigned the address of pump number 1, and the other will be assigned the address of pump number 2. In order to turn on the 2 pumps when the low-level switch is energized, we place an open contact here and assign it to the address of the low-level switch. As we know already, the switch has an open contact inside it, and when the level of the liquid in the tank drops to the minimum, a 24-volt signal is sent to the I00 input, causing this contact to be closed and the set input to be energized, resulting in the 2 pumps being turned on. Now that our pumps are running, at what point should they be shut down? Well, as we said before, the pumps should run until the level of the liquid in the tank rises to its maximum when the high-level switch is energized. So, let's insert another open contact here and assign it to the address of the high-level switch. So now, when the switch is energized, both pumps will be shut down. We also add the address of a memory bit here for the flip-flop. Okay, so after the tank has been filled and the pumps shut down, we want this mixer to start up automatically to mix the liquid in the tank for 7 seconds. So first, we need to add a new network here, then insert an extended pulse timer here, giving it an address of TO. Now, we add an open contact here for the set input, assigning it the address of the high-level switch. And then, we add a coil here for the output, giving it the address of the mixer. Now we need to set the duration of time for the mixer to run in the time valve input, using S5 time formatting. In our case, we want to enter 7 seconds. So first, we enter S5T, then the pound sign, and then 7S, which represents 7 seconds. We also need to add an open contact and assign it to the address of the valve for the reset input. Now with these settings, when the high-level switch is energized, the mixer will be turned on and run for 7 seconds. So because the reset input has an open contact with the address of the valve, the mixer can never be energized while the discharge valve is open and liquid is being discharged from the tank. Now, what should happen after the mixer is turned off? That's right, the discharge valve should open to discharge the liquid from the tank to be used elsewhere in the factory. So now, we need to insert a new network and insert another SR flip-flop here. Now, which one of the outputs do we need to turn on with this flip-flop? Yes, it's the valve that we need to activate with this instruction. So we place a coil in the flip-flop output, assigning it the address of the valve. Now, when exactly should this valve be energized? Or in other words, when should the valve open? Right again. As we said earlier, the valve should open after the tank has been filled and the mixer is finished mixing the liquids. So we need to insert an open contact for the high-level switch here, and following that, we insert a closed contact for the mixer. With these settings, when the tank is full and the mixer is off, the valve will open. So how long will the valve stay open? Well, it will remain open until the level of the liquid drops to the minimum set level, which means the tank is fully discharged at this point. So which one of these facilities will be energized when the level reaches the minimum? Right, the low-level switch. So we should insert an open contact into the reset input so that when the switch is energized, the valve will be closed. We also assign an address of M01 to the flip-flop memory. Okay, our program is almost complete, but we also have a stop switch here. Stop switches normally remain closed. This means that the contact within the switch usually remains closed, allowing the signal to pass through them. When the switch is pushed, the contact is opened and the signal is disconnected. The stop switch here is normally closed too, so we can add a closed contact on the reset input of this flip-flop. And we can also copy and paste it for the other networks. With these settings, when the stop switch is pressed, all outputs will be turned off. So that completes the programming. Now, we can save our program and move on to test it. Here, because we are using PCS7 instead of Step 7, this download icon is disabled. So we need to go to the Somatic Manager and click on this icon in the toolbar to open the online window. In the window, open the Block folder and drag the OB1 from the offline window to the online window like this. The offline window contains our computer's data, and the online window contains the PLC's data. This HMI station has been added to the project tree because we're going to use WinCC Flexible to test the program in addition to the PLC simulator. But it's not imperative to use this station. You can test the program using the PLC simulator alone. Okay, now we're going to put the CPU into run mode, and then put the program into online mode. We know that the stop switch is normally closed, so we need to close it manually in the simulator before we can test the program. So to start, we first energize the low-level switch, and as expected, pump numbers 1 and 2 are both turned on. Note that in the simulator, the relevant outputs of Q40 and Q41 are now true, and illustrated in this graphic, you can see both pumps are turned on and are pumping liquid into the tank. When the liquid rises past the level of the low-level switch and it stops being energized, the pumps will continue operating because the tank is not yet full. When the level of the liquid rises to the maximum, the high-level switch is energized, which turns off the pumps and starts the timer. Here, you can see that the mixer is going to be turned on for 7 seconds, and after it's been shut down, the discharge valve will be opened automatically. This process continues until the level of the liquid drops to the minimum again. At this point, the low-level switch will be energized again, the valve will be closed, and the pumps will be turned on, thus repeating the cycle. At any point during the machine's operation, if we press the stop button, all the outputs are turned off, as you see here. Okay, so in this lesson, we learned how to write a program to control this machine automatically using an S7-300 PLC and Step 7 software. Thank you very much for watching this video. Make sure you subscribe to Parsec if you haven't already, because we've got some more awesome videos coming your way very soon.